Reaction number 6, they call it as oxo process. It is also called as hydroformylation, and people also call it as carbonylation. We'll see why. What happens in this oxo process, if we have an alkene, let's suppose take it as propene. Suppose if we have propene, and if I add carbon monoxide and hydrogen and a lot of heat and very high pressure, and in presence of a catalyst like tetracarbonyl cobalt, then I get this group added on this alkene. So this is formyl group. A formyl group is getting added on this carbon, and there's a hydrogen getting added on this carbon. So they call it as a hydroformylation. Hydrogen has been added and a formyl group has been added. This is hydroformylation, and we have talked that this is a carbonyl group. So and carbonyl group is getting added, so people also call it carbonylation, or more famously they call it as hydroformylation. But the standard name of this reaction is oxo process. As you can see, what's happening is a formyl group is getting added. Now this reaction is a very important reaction in industrial chemistry, and this is considered as one of the important reactions that we have known in 20th century in the field of industrial chemistry. Now we will not delve deep into the mechanism how this happens. We'll just get an idea of what must be happening, and just will be happy to know the name of the reaction, reactant, reagent and product. Because this reaction occurs through formation of complex, and those complex are really complex. So we don't get into those complexes which are complex. So we just get an idea of what would be happening, and just to get a feel of what would be happening. And nobody is going to ask the mechanism, because when the mechanism is not clear, we don't look at the mechanism, because we look things for clarity and not to bog down ourselves with unclarity. So I'm not going to tell you the whole mechanism of this, but what happens is this is a complex, and this is a complex. So this alkene gets added on this complex, and one of the carbonyl group comes out of the complex and gets added on the alkene. And the carbonyl that we have induced in high pressure, when carbonyl comes out of this complex, these carbonyls comes into the complex. So when this alkene comes out of the complex getting added by this carbonyl, so it comes out. So that carbonyl which is coming out of the complex and getting added on the alkene is refilled by the carbonyl group that we are adding from outside. So the status of these catalysts remain as it is. Carbonyl comes out, and then from here that is refilled. So pressure has to be high, because this carbonyl has to be pressurized into the complex to form a stable complex. And the hydrogen that we are adding will break down in the form of H dot and H dot, and will get added on this carbon, because when one of the carbon is adding a carbonyl group, then that will break as C dot. So this will also break as C dot. So this C dot will get added or get dimerized, not dimerized, will form a bond with this H dot. So C dot and S dot will form a bond. So as you can see here, that one of the hydrogen has been increased. Right. Similarly, one hydrogen will be required for this carbonyl. Now the structure of carbon monoxide is like this. It's like this. Right. So at the time of the reaction, the oxygen takes its electron back. So it becomes like this, and carbon has 2 unpaired electrons. So this 1 unpaired electron is going to form bond with this carbon. As we can see here, this carbon is coming from carbonyl group and is getting added on this carbon. So another dot is going to be added by H dot from here. So one H dot is going to get added on this carbonyl, one H dot is going to get added on this carbon. So one hydrogen has been added here, one hydrogen has been added here. Fine. So that's how it goes. So this much of idea is enough for this reaction. So this is oxo process. The problem with this process is that there is a equal chance that a isoform is also possible. This is butyraldehyde and this is isobutyraldehyde. So this carbonyl group, if gets added on this carbon, we get this product, butyraldehyde. If this gets added on this carbon, if the carbonyl group gets added on this carbon, we get this product, and this is isobutyraldehyde. Now, generally, we would like to produce one of them, not both of them. So if I am trying to produce butyraldehyde, then side by side isobutyraldehyde will also be produced. Then there is a heck of separating them. So this is not the best reaction to produce aldehyde, but if I am interested in both of them, then this can be used. And the research is going on for a catalyst that will selectively produce one of them, either butyraldehyde or isobutyraldehyde. And as research is going on, we don't have to bother about that, because when research will be completed, they'll tell us about it in the form of text and then we'll study them. For now, research is going on, so no more talk about that. 6 reactions we have done for the method of preparation of aldehyde, and those are all the 6 reactions that we have to do. There will be some reaction that will produce a mixture of aldehyde and ketone. We will study them after studying the method of reaction of ketone. So aldehyde is done. Now we'll study method of preparation of ketone, and after that we'll study certain reactions that are used for producing both mixture of aldehyde and ketone. That's how it will go. Now before closing this section of method of preparation of aldehyde, let's solve some problems. So let's starting with the simple ones. Suppose I have styrene and I'm carrying out a reaction with carbon monoxide hydrogen with heat and pressure and in presence of a catalyst tetracarbonyl cobalt. This gives me A plus B. Now I can get B if I take diborane and a base in presence of hydrogen peroxide, starting with C. So identify A, B and C. Identifying A and B will be a walk in the park, because this is the last reaction that we have done. So you should be able to do it. You will not be able to do it if you don't know what styrene is, and if you don't know what styrene is, then my friend, I'm sorry for you, because we have seen this molecule many times before and I've told you this important. Styrene you should be able to know, you should know. A and B you should be able to figure out. And this is the reaction that we have done in this very topic in the method of preparation of aldehyde. So you should be able to know this reaction, what it is, you should be able to know what C is. Considering that you people are smart, I'm directly drawing A, B and C. This is what I think A should be. This is what I think B should be. And I think C should be this. What do you think? Do you concur? Give some time, get your own answers and cross-check by mine. I suppose I'm right. Right? So this problem is done, no more discussion.